5 sine 20t plus 12. Up there, 1, an inductor of 100 millihenry, a capacitor of 15 millifarad, a 2 ohm, (150 millihenry), and another current source here, AC current source, of the value of 2 sine 20t, not 200. Now something made me think about this for a second. I'll explain that. And the question is, find the voltage across the capacitor. What is VC? This is VC. Find that voltage. My questions, I started thinking about it. What will happen if this was not 20t, that was 40t? Because remember, these guys 20t, that means W is 20, right? So the inductor is j omega L. The value of the inductor, ZL, is j omega L. And ZC, it's negative j over omega C, or 1 over j omega C. And ZR for the resistor, the impedance, stays the same as R. So what happens if this is 40 and this is 20? How are you going to find what ZL is? What are you going to use? Are you going to use 20 or 40? So we got a problem. That doesn't mean it can't be done. What we have to do in that case, use what? Superposition. Find the answer to this source, kill that source, find the answer to that using W being 20, then kill this source and find the answer to that one using what's 40. So in this case, we are lucky. W is what? 20. So let's see what the 100. So Z for the 100 millihenry will be j omega, which is 20, times 100 milli, and 100 milli is what, 0.1? And that's 2j. Z for the capacitor, the 15 millifarad, is going to be negative j over 20 times 15 milli, 0.015. Negative, let's see, what's that number? 20 times 0.015, 0.3. For, is it 10/3? I think. Negative 10/3 J. And for that 150 millihenry, is going to be J times omega, which is 20 times 0.150. I think that's 3J. So now I'm going to convert my circuit to phasor. This source here this source here, I'm going to write that, what, 5 angle, what, 12? Oh, wait a minute. Let's stop here. It's not 5 angle 12. This is cosine. I thought it was cosine, sine. Right? So let me go back here. We know if this was 5 cosine 20t plus 12, you can write that as 5 angle 20. Because the rule says what? If you have a cosine wt plus phi or theta, whatever you want to use, you can write that in phase as a angle phi. 5 angle 12, yes, thank you. 5 angle 12, yeah. So now I need to convert the sine to a cosine. And the question is, do we add or subtract? Do we add or do we subtract that 90 degrees? So let's see, sine, I'm just doing the sine. Sine wt plus theta, doesn't matter. I'm going to change it to a cosine. And the question, I'm going to put plus or minus. We need to decide that in a few minutes here. See if it's plus or minus. So I'm either going to add 90 degrees or subtract 90 degrees. Well, let's pick a value. What happens if you let Wt equals theta? Or you can do negative theta, make life easy on you. Negative theta. This becomes sine of what? Sine of 0, which is what? 0, right? If you let Wt equals negative theta. What happens if you let this equals negative theta? Is it be cosine 90 or cosine negative 90? That doesn't really tell you much, still 0, right? So that wasn't a good choice. Okay. So, you know what? Let me drop the theta out, because you can't judge by that unless I start doing like theta over 2, which make my life more complicated. And let's see what happens. So let me use some numbers here. Let Wt equals, I don't know, what do we know the answer to? 30 degrees? So this becomes sine of what? Sine of 30, right? Now let's look at the cosine. This will be cosine, and it's either 30 plus 90 or 30 minus 90. Which one is it? We know sine of 30 is what? 0.5. So this is going to be cosine of either 120 or what? Negative 60. Now, I can tell you the answer quickly. Why? All student take calculus. If you want the answer, notice your answer is positive. So you want the answer to be positive, right? Where is the cosine positive? Here and here. It will never be positive in this quadrant. Where's the 120? In this quadrant. So this is out, because that'll give me a negative. Cosine 120 will be negative 0.5, where cosine negative 60 is positive 0.5. So we're finding out that if you go have sine and you want to change it to a cosine, what do? You subtract 90 degrees. What I did here, just tried to remind you, like if you can't remember if it's addition or subtraction, that's how we go about deriving that. But the rule is if you have a sine, you subtract 90 degrees. So I'll just make that a rule here. So here's the rule. If you have A cosine theta, or WT, plus theta, or sine, I'm sorry, I'm trying to change sine to cosine. Should go back to sleep this morning. You can change it to what? A cosine WT plus theta, and you got to subtract 90 degrees. You're always going to subtract 90 degrees. Derivation, we just finished deriving that. So this is a sine. Subtract 90 degrees from 12. What's 12 minus 90? Minus 78. I use boxes now. This is 1. 2j. Negative 10 over 3j. 2. 3j. And this will be 2 subtract 90 degrees from that. What's 45 minus 90? Negative 45. It is sine. You got to convert it to cosine first. You subtract 90 degrees, then you switch it to phasor. Now, I can apply source transformation here. The question is, what's the voltage across the capacitor? What's this voltage right here? Do they have a direction for it? Yes. They want it plus here, minus here. VC. I can do a source transformation here. I can combine both of these into one. The product over the sum. Negative 6j, when you multiply them. 0 comma negative 6. Divided by, oh, not negative, plus 6j, right? 2 times 3j is 6j. 0 comma 6. Divided by the sum of them, which is 2 plus 3j. And my calculator always gives me an answer in polar. So I got 1.66 angle 23.7. Oh, 33. My eyes are bad. 33.7. I can do source transformation. What will happen to this source? Becomes what? Current, right? Today is my off day. You change the voltage to a current source in parallel. These two are in parallel, the product over the sum. I can put this in phasor. Negative j is negative 90 degrees, 3.33, negative 90. since I'm start to go in Phasor here. 1.66 angle 33.7. To angle negative 45 degrees. Now let's find the value of that, the product over the sum. That's 2j divided by the sum, which is 1 plus 2j. And it's 0.89 angle 26.6. I can do one more source transformation. I can convert this to a voltage source in series and convert that to a voltage source in series. And I will have only one loop, which means one equation by one unknown, or even voltage division. So this will be a voltage source. The value of that is the product of these two. Times 5 angle negative 78. 4.47 angle negative 51.4. Voltage source now in series with 0.89 angle 26.6. 3.33 angle negative 90. 1.66 angle 33.7. And a voltage source here of the value of the product of this times this. 2 angle negative 45 times 1.66 angle 33.7. 3.32 angle negative 11.3. Since I want the voltage right here, notice if I travel this way, I could, but what happened to these sources? This is negative to positive, this is what? Positive to negative. So I got to subtract them. So I can reduce that to one source if I want to, and the value of that will be this one minus that one. I'm putting minus to plus. So I'm going that direction. I got to subtract from it because if I go this way, that's plus to minus. So it's this one minus that one. 4.47 angle negative 51.4. I can do also one. Oh, wait, clear it. I have 3 sitting in the front. 4.47 angle negative 51.4 minus 3.32 angle negative 11.3. And I came up with 2.88. Hopefully I'm pushing the right button.
I got the same thing.
Angle negative 99.3. I can take this and that, add them, make one impedance out of them, and leave that one, the 3.33, down there. So this is VC. I can take this one and this one, combine them into one. They're connected in series. Doesn't matter if there's a gap between them. So let's add them. 0.89 angle 26.6 plus 1.66 angle 33.7. 2.55 roughly angle 31.2. And now if you want to find VC, what's the easiest way? Isn't it voltage division? VC equals 2.88 angle negative 99.3 times that impedance over the sum of them. Negative 99.3 times negative 90 degrees. And again, if I push all the good buttons here, the voltage across the capacitor, which is 3.24 angle negative 146.6. Now I got to change it back to time domain. So it's VC as a function of time. It's going to be 3.24 angle time domain cosine WT, W is 20t minus 146.6 degrees. To go from cosine to sine, we need to add 90 degrees. So, or 3.24 sine 20t minus, let me add 90 minus 146.6. And that's negative 56.6. And that's your voltage as a function of time. So we change the problem from phasor to, from time to phasor, solve it in phasor, change it back to time. And it took a few minutes to do it. And a few mistakes by me in the process.